All right, so I'm going to show us here graphing the inverse cosine, or arc cosine is another way to write it. Two different notations. I'm going to start off the same way I did in my last video with inverse sine. So I already have the cosine graphed here. This is just regular y equals cosine x. And I'm going to graph the inverse. So this is not the inverse cosine function, because if we take those points, so our first point on this guy is 0, 1. We're flipping that to 1, 0. And then I've got pi over 2, 0 over here. That'll be 0 pi over 2. And I'm going to keep going in this fashion. So like we did in our last video, I just now have our cosine graph, but snaking up our y-axis. And I think it's always easier to kind of turn my paper or tilt my head and graph this literally just like we would our cosine. If you're on the computer, you can literally copy and paste and turn it over, and we got our cosine graph. But as we know, this is not a function here because our range is negative infinity to positive infinity for the new graph. So they do the same thing for this. So I think you should graph this guy, inverse cosine, using that inverse button, or inverse notation on the calculator, and see what portion of this graph they took. So again, you can pause me and check it out, and I'll keep going in a second. So for the inverse cosine, we wanted the whole domain from -1 to 1. So they actually took that top part from 0 to pi, right? If I took any of the negative, like this yellow that I'm highlighting, it wouldn't be a function. So my range is a little different than we had from sine, like I was saying. So it's from 0 up to pi. So we get these three key points, 1, 0, 0 pi over 2, and -1 pi that we'll use when we transform this graph. So our new domain, -1 to 1, my range, good to pick out 0 to pi. And again, I always like to think about that on the unit circle. I have this picture of where we can get outputs for our inverse cosine. So when I put, now we're going to put ratios into this function. Our outputs need to be in this area of our unit circle. So I really like to correlate those two kind of images in my head. I'm really a unit circle person, I think, as I go through this. Okay, so I'm going to do the same thing with tangent, and you guys can pause, fast forward, go back, but I already graphed my tangent graph, and this guy should say tan, not sine. So if you didn't graph that, pause it and graph it in there, and then everything flips. I'm switching all x's and y's. So now I'm going to have horizontal asymptotes at pi over 2 and -pi over 2. And I'll flip my points. So 0, 0 stays the same. But this guy, 1 pi over 4, well, pi over 4, 1, is now 1 pi over 4. So it goes up here. And then we have our opposite on the other side, -1, pi over 4. So that would be one kind of branch of our inverse tan function, right? And if I actually graphed the full inverse, I would get all these multiple branches. So again, to start, this is not a function. If we just take the graph and switch x's and y's, but they make it a function. And tangent is a lot easier to make into a function because we just take this middle branch that's already segregated from the others. So originally, hopefully we had some practice with this, our domain is just we can't have all of those pi over 2's, but our range, -infinity to positive infinity. So what I highlighted in yellow is our inverse tangent graph. So we've got two horizontal asymptotes at our pi over 2 and -pi over 2, and then those three key points, 0, 0, and 1 pi over 4. And then we take that inverse shape going there. So notice our range for our inverse graph is very similar to what we had for the sine curve. Negative pi over 2 to pi over 2, but I can't have pi over 2 or negative pi over 2. So kind of like if I do open circles on there, almost like a number line. Our outputs, our answers, can be anywhere in quadrant 1 and 4 between negative pi over 2 and pi over 2. So again, we'll see how that unit circle kind of helps us in the next couple practices we do in class going through. All right, guys, so feel free to, again, rewind, go through these videos. These are going to be the practice graphs that you do. You can use Desmos to check, please do. And I would just do this. We only have 3 key points now, so I like to make my T-chart using the 3 key points. For tangent, I throw in the asymptotes also, and then transform it, just like we did with our sine and cosine curves, but they're not repeated. There's no period or anything for these, so it should be a little simpler. And reach out if you need help.